Welcome to another episode and video on my Arduino MegaADK for Android originally, but in the start of the series I experimented with Android and it turned out not a good combination, because Android suitable for the MegaADK has to be newer than version 2.2, and that's not where my Android comes in. It is a 2.2, so too old. Anyway, it has lots of possibilities equal to the 2560, and well, as you can see, a breadboard with electronics and some fischertechnik mechatronics, and since last time also reconstructed well, tower or pinnacle for phototransistor, also fischertechnik, and I replaced the LED lamp, the lens lamp actually, with a flashlight, and this way it is brighter, because it turned out that the lens lamp that I used doesn't burn as bright as should for this whole combination. So it is connected to a voltage divider, and then in one way connected to analog input, and one way to digital input. Although I now notice that the wiring is gone, so I have to see why and how. And this is actually the whole wiring to the digital input, no, to the analog input, which should be here. So this means that the probe has taken it out, which is not good. Let me see that I can restore it, and there it goes completely. Hopefully with pliers I can manage. Not really. It did work. That may be obvious. It's a thin wire. That is one. Now, carefully into its socket. Alright, that should work. But the point is, with this probe I want to measure if it gets a signal, because, and that is the whole problem right now. Let me see if this works better. Nope, I need some support here. The problem is that despite the stronger signal from here, this is quite strong, I did not get a plus or a zero. It stayed all zero. So I need to investigate that. So let me take an old-fashioned battery pack and try to connect it anyway, if I manage. That is one thing, and now it doesn't fall down, but the wire has gone again, so I need another solution for this. What else? Well, trying to get the mechatronics working, but let me first focus on this part. Alright, I managed to push it in anyway. However, I made a mistake right here because I pushed it in A5 and it had to be in A4. Because when I go to the schematics, it says A4 and 7. This is 7. Oops. And this is 7 and this is A4. So now it's correct. The question is it indeed working? Well, let me activate the flashlight. And now I should be seeing things. Well, I see indeed some voltage level, but is this working? That's the big question. And no, it's not. And this 00 is not what I want to see. So let's look at the software. Oh wait, that's a nice one because the lamp is gone. The lamp is definitely gone, which was from here. Okay, so the lamp was activated from here, but the lamp is gone, so I need to apparently change the code. Digital pin out is no longer there. Well, it is there, but no longer in use. So what need I to do? No longer digital write. But I do need high and low. I do need high and low, but how? Anyway, I can scratch this and I can scratch this line, because this is digital input to lamp and this is digital input to lamp. No longer there. I do read pin 7. Oh wait, it is okay. This makes no sense anymore. No sense at all. This is pin 7 and this is A4. And where's A4? Right here. A4 gives the analog value. This one. A4 just gives a digital value, but 7 needs to be different now. So digital pin 7 is not high. It is just digital pin 7. So this one has to go. That can be. And digital in pin 7 is whatever comes in. So whatever comes in. What does come in? Compiling. Done. Alright. So now it is 0 digital in, which is not good. Which is not good because the lamp is shining. It should be 1. Now let's be careful. This is 7 indeed. It is the purple probe, and the purple probe is the second from below. So it is this one. Why is it detecting nothing? It is this line. I should be seeing a 1 now. So why is A4 giving a nice value? What I could do is from right here measuring what voltage is, detecting if it is higher or lower than the maximum input, and then find out if I can skip this voltage divider anyway. I think that's a good idea. So let's measure the voltage. Right, so keep an eye on this line. This line right here, this unit is 5 volts. So what do I measure when I am probing here? That is yeah, how much is this? Oh, this is the division of 5 volts, so it's 3 volts. Because here I can measure, it is 5 lines, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 5 volts. So right here, 3, 4, 1, 2, 3, 4, 5. Measuring gives right now 2 volts. No, I'm looking at the wrong one. I'm measuring 3 volts. And 3 volts is really in the limit of within the range that Arduino can safely get. So what if I take another wire and put that somewhere else than originally intended? I do have enough wires, but do they fit? That's a very different question. And I want them right here. So this wire is too short. Yeah. Another wire that's too short. And okay, most wires I have available are too short. So let me take then this experimental wire, which is actually no wire, but let's just put it in. And which one should I use? Well, I have still available pin 13. So the choice is right now with this one 13. Let's see if I can make that. I'm starting to doubt. It's quite a distance to cover. Alright, this is 13. So now I have to program 13 to receive the same signal, or to receive the signal anyway from 13. So yeah, let's program something. And alright, analog in pin, no, digital in pin. Um, 13 is 13. And then here pin mode 13 for input. And then let's take right here, copy two lines, and make this 13 and make this 13. And now I should be able to see what works. So this is the original voltage. Okay. Here comes the original voltage. Here, after the voltage divider, well, it converts the voltage to a lower one. It transforms the voltage. So let's see. Whatever happens, happens. Upload. Hey ho ho ho. What is that? Right. Typo. Digital in 13. Done uploading. Very good. But now for some results. 7 and 13. 0. Ooh. I did not expect this to happen. So the voltage divider is not the culprit. I did not expect this to happen. Alright, let me put this probe now for some time here. Switch it off, switch it on. Alright, the voltage is 4 volts. And what does 13 do? 1. Aha. What was the difference? I have no idea. So between 3 and 4 volts No, 2 and 4 volts. Oh, that's a big difference. So this one, which is actually this line, see the mouse cursor, I could put my finger. So this line is measuring straight from the phototransistor, says 4 volts. This one is measuring at digital 7, and this one is measuring after, and I see another wiring issue now. This one is measuring after the voltage divider, which is 2 volts. And I have one again to put this straight. This is not nice. This one needs to go in a 4. So why doesn't it? That is better. Alright. So now let's see if when I switch off the flashlight, what happens. "13 is down." I switch it on and 13 is 1, but 7 is still down. Alright, so conclusion is actually that the voltage divider is not doing what it should do, or well, it is doing what it should do, but it brings the voltage down too much for this use. Interesting. So what use is the voltage divider anyway? I brought it in for safety, because in another project which does not involve an Arduino, not using a voltage divider, I blew up a port. So I thought, okay, and that was involving a phototransistor. So this does work, clearly. With the phototransistor, same one, it gets its power on the same way, but the power is apparently different, which is kind of surprising, but so be it. So right now it's a bit of strange, but it works, and that is what counts. So now I have to change the wiring schematics, because this is now going wait, I have to do it a bit different as well, because I am now putting it from here to another port, which go here, and this is 13, wiring from here to here. And digital as well. So this is how it is. Next, question. Alright, last part of this video, and let me check other stuff as well. Not to improve things, but just to check if things work. And then it is very nice if you have the tools ready. Right here. So let's see if this can still work. Not really. Okay, that is because this one is kind of not really working, and it was the signal that I'm not measuring right now, but last time it gave the problem. So let me move this once again. Right, yeah, that should be then right here. And this wire always nice if wires cooperate with what you want. I do hear the whining. But yeah, alright, now it works. So that's a point of seeing how things, why it doesn't work within the circuit. Then right here, yeah, that apparently does work. Or not? No, has no influence. Alright. This one was quite curious. Last time this one, pressing this button, flashed this light, and after that it just burned. See? Just short flash. Once again, a short flash. And once again a short flash. That's 3 times. And this is what should happen. Just a short flash because it discharges. And last time, after a few quick discharges, it kept burning. And that is not happening right now. This is alright. So I'm happy with that. Not with this, because why does this stop? Should not happen. Slowly getting back to normal, although the problem is still, as you could see in the serial monitor, that with the declaration, all ports have their values, and I should still check out why that happens. But given the fact that the outputs are giving their wanted results, ones, zeros, with a voltage divider that can go factually, it's alright. So thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up, like it, leave a comment or suggestion. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. Please show your support by making a small donation. Very much appreciated. You can also choose to become a patron and have your name mentioned as a supporter. More information at the start of this video, but also below this video with a link to my website with lots of information and other projects. once again, thank you for watching, and this is to be continued. So, bye bye.